Good day, stats students. So today we're going to go over section 9.2 part 1, and so we're going to get into some more generalities about testing the population portion P. So we're going to calculate test statistics, we're going to calculate p-values, okay, and then in parts 2, 3, and 4 we'll get into more specific problems. The hardest thing about calculating a test statistic, and you're probably going to be surprised about this, believe it or not, is knowing your symbols. If you do not know your symbols, you're going to have an awful lot of problems calculating test statistics and running a hypothesis test. So the formulas have things like x bar, mu, p hat, p, n, s, all those things. And if you don't know those symbols, what they mean, you can't calculate your test stat, you can't run your hypothesis test. So you got to know your symbols. I beg of you. Please memorize them from now on. All right, so remember this formula? Back in chapter 2, we had this guy right here, okay? And, well, here, the test statistic is going to look awfully familiar. It's still going to take this form, okay? But instead of using a standard deviation, we're going to use a standard error. Remember, standard error is just a modification of the standard deviation, the sampling distribution of a statistic, okay? So it's the same concept here. So when calculating the test statistic when testing the population portion P, here's the formula. First thing I want to point out to you is that I put a little TS here to stand for test statistic. And there's a reason for that. Okay, we'll get into that here in a second. Here's the formula. We'll go over the specific pieces parts here in a little bit. First thing that I need you to know, please understand this one, is that the Z test statistic is different than the Z critical value. Critical values are different than test statistics. You cannot substitute one for the other one. Do not substitute. They are two different concepts. So remember, when creating a confidence interval for the population portion P, and let's say that you're creating a 95% at the 95% level, what are you going to put in there for the critical value? You're going to use 1.96. Okay, here this is a calculation. Okay, and it's specifically for hypothesis testing. Test statistics are different than critical values. Do not substitute one for the other. Two different concepts. P hat, that is the sample proportion. We know that. That's x over n. N is the sample size. So really the piece that we don't have is what exactly is p sub 0. So this right here, it's just one value. It's p sub 0. So the PowerPoint didn't do a very good job in showing it that way, but that's what it's supposed to be. It's P with a little sub-zero there. Okay. P sub-zero is the value of the null hypothesis. All right. So where else have we seen sub-zero? So what they're trying to do by putting this little sub-zero there is trying to remind you that what? That, okay, if you see a sub-zero, all right, where have we seen sub-zero before? We've seen it for the symbol for the null hypothesis, H sub-zero. And so what they're trying to do is get you to associate sub-zeros with the null hypothesis. All right. So basically, the way you got to think of the null hypothesis when testing the population portion P is that it's P is equal to some value, and that some value, what we're calling is P sub-zero. So whatever value here is in the null hypothesis, that's what we're going to throw in here into the formula. That's it. So what's the concept here? The concept here is that, okay, we're taking our p hat and we're seeing how far away p hat is from the value in the null hypothesis. When you do a subtraction, that's what you're doing. You're seeing how far away they are from one another. So remember the concept for hypothesis testing. We don't test directly the researcher's hypothesis. We test the opposite. What's the opposite? The null hypothesis. So what we're doing is we're seeing how far away the RP hat from our random sample is from the value in the null hypothesis. And then how are we going to measure that? In terms of standard errors. How many standard errors is that? That's the denominator. That's all we're doing with the test statistic. Okay? So here's a problem. A researcher wants to test the proportion of U.S. drivers that drive a foreign car. He randomly samples 100 U.S. drivers and 45 drives a foreign car. Tests the 5% significance level if the proportion of all U.S. drivers that drive a foreign car is greater than 40%. Okay, let's take this step by step. What is p hat? All right, so, well, in thinking about p hat, we have to think about what is a success here. The success here is that we find a person that drives a what? A foreign car. And that's what X is, the number of successes. So how many successes did we have? We had 45 out of 100. And that would translate into 0.45. So you think about what your success is, okay? How many successes did we have in our sample? That's X. We divide it by our sample size, that's N. Throw that in your calculator, you get your proportion, 0.45. There's your p hat. So we know 45% of our sample drove a foreign car. N is a sample size, obviously that's 100. We know that. Okay, so remember, p sub 0 is the value in the null hypothesis, so we got to figure out what's going to be in the null hypothesis. So let's see, it looks like we're going to put here p is greater than 40% in the alternative. Okay, so notice in the alternative we have p is greater than 0.4. That's what we were testing. Test if, right, if the proportion of some sort of population is greater than 40%. P is greater than 0.4. That means P is equal to 0.4. So what's P sub 0? This value right here. Okay, that's it. And that's what you would fill in for P sub 0 in the formula. So if you fill in the pieces parts, notice you got here 0.45 minus 0.4. Okay, there's your standard error down here. Okay, we go ahead and calculate, and we get 1.02 for your test statistic. So that's how you calculate a test stat for testing the population portion P. Can your test stat be negative? Sure. That just means that your p hat, your individual observation, was what? Less than the value in the null hypothesis. So can you get a test statistic that's negative? Certainly. Z-scores can be negative. All right. So if you have your TI calculator out and you want to follow along, pause the video, go get it if you don't have it. Once you get it, start the video up again. All right, let's assume that you have your calculator now. All right, if you have a TI calculator, and this is the way most calculators would work, is that this can get a little frustrating for students. So if you want to do the whole thing at once, hey, that's good. But what you got to remember is that you have you got to think of parentheses up here, because remember, you have a line that goes straight across. That means you got to do all of this and all of this separately, okay, and divide in the end. You can do this in pieces parts if you wish. That's fine too. Okay, but if you want to do this all at once, you would have to do in parentheses 0.45 minus 0.4, close parentheses, divide by, hit your square root button, and then it'll automatically give you the left-handed parentheses. Then you got 0.4 times in parentheses 1 minus 0.4, divide by 100, close your parentheses. So if you want to do it all at once, there you go. If you want to do it in pieces parts, that's fine too. Word of warning here. Okay, word of warning is that, remember I told you back in, I think it was chapter 2, that we went around our our z-scores to 2 decimal places. That is absolutely true right here. Reason why I was going to use our standard normal table, right, to figure out some p-values here in a little bit. Okay, here's the word of warning. Okay, is that when they say round to 2 decimal places, they mean this final answer right here. Notice I took this out to 4 decimal places. Honestly, I'd rather leave all those decimal places in your calculator. If you calculate the whole thing like this, you don't have to worry about rounding into the end. But if you're going to do it in little pieces parts, do not round this to 2 decimal places. That needs to be like 4 or 5 or maybe all 9 of your values in your calculator. Okay, what you want to round is this value right here to 2 decimal places. Do not round to 2 decimal places before that. And you're going to get massive rounding errors. Okay, so please keep that in mind. So what exactly does this mean? What this means is that our sample proportion p hat was 1.02 standard errors above, because because it's a positive above the value in the null hypothesis. So our p hat was just over one standard error away from the value in the null. Okay, and we got to figure out how rare an event that was, and that's the probability value, the p-value. All right, so let's do this. Let's go through various examples in calculating p-values. Okay, I showed you how to calculate your test stat. Let's get into calculate the probability values, the p-values. Okay. All right, so when you have a left-tailed test, now how do we know it's a left-tailed test? We have a less than sign in the alternative hypothesis. Okay, so less than sign, left-tailed test. All right, let's say that we went ahead and already calculated the test statistic, and it turned out to be, in whatever situation, it turned out to be a negative 2.51. All right, so that meant our p hat was 2.51 standard errors below the value in the null hypothesis. All right, and so I went ahead and had StatCrunch draw this for us. So here is a negative 2.51 right here. So, you know, negative 1, negative 2, negative 3. Remember, this is in terms of z, okay, of z's. Okay, so that looks right, a negative 2.51 right about there. And when you have a left-tailed test, what you do is you simply figure out the area to the left of the test statistic. And so I'm trying to depict in red with StatCrunch and try to get you to visualize the area associated with the p-value. Okay, so remember, this total area underneath this curve is 100%. Look at this area right here. Does this look like a big area to you versus the rest of this stuff underneath there? I hope you say no. So what this is telling us is that our p-value should be pretty darn small. Okay, so I'm trying to get you to visualize the p-value. So I literally draw this in class every single time. So when we calculate a p-value, and it's based upon the standard normal table, z, okay, I draw this, and I want you to draw it too. I want you to try to visualize your answer. Okay, notice small little coloring here, small area, small probability value. Okay, so now how do we go calculate the p-value in this situation? Well, because our test statistic is in terms of z, we're going to use the standard normal table. So remember this table right here? So you got your appendix A and stuff like that. I want you to go get that. Okay, if you don't have it, pause the video, go get it. Okay, make sure you have the negative side and the positive side of things. Remember, this is you got the one side that's negative for z-scores, you got the other side that's positive for z-scores. Make sure you got both sides. Okay, so let's assume that you got your table. Okay, so let's go back to our test stat. We're looking up a negative 2.51. All right, so I've gone ahead and just did part of it here, okay, and placed it in the presentation here. So remember what it was, a negative 2.51. All right, so negative 2.5. Here's 0.01. We see where that comes together. Okay, and remember, this table right here is always giving us less than. So if you are doing a left-tailed test, you get to just look up your test statistic here, and that's your p-value. That's your probability value. There's nothing else to do. That's your p-value, 0.0060. Okay, that's it. That's all there was. That makes sense, because notice that value right there is very, very small, isn't it, in terms of probabilities? It's less than 1%. So what we're saying is that less than 1% of this area right here in red, okay, less than 1% of the total area underneath this curve is in red right there. Okay? All right, next one. Also a left-tailed test. This time we're looking up a negative 1.68. Here's a negative 1.68 right here. Okay? That makes sense. left tail test, we're going to shade this in. Okay, get your paper out, shade it in. Should look like my picture right here. Okay, now that's going to be a little bit bigger than the last one, right? It's going to be a little bit bigger p-value. All right, so look in your standard normal table, negative 1.68. Negative 1.68. We're down this column right here. There's our p-value. Negative 1.68, 0.0465, 0.0465. There's your p-value. There's your probability value. Okay? Left-tailed, just look it up. All right, let's change over to right-tailed. Okay? So right-tailed, here our test statistic is now 1.02, so get your piece of paper out, draw your bell-shaped curve, put in your scale right here, 0, 1, 2, 3, just like we would do it in class, negative 1, negative 2, negative 3. 1.02 is just barely past 1, right? So this time, since it's a right-tailed test, you're going to shade to the right. So here's 1.02, we shade to the right. Okay, and now that area in red represents your p-value. What percentage did we shade it in underneath this curve right here? How much did we shade in? What percentage? That would be your p-value. Now, remember when we look up 1.02, remember what the book is going to tell us. It's going to give us less than. It's going to give us what? This part right here. Okay? Now, if I told you that the unshaded part was 0.9, that means the shaded part has to be what? 1 minus 0.9 or 0.1. And so whatever we find out is the unshaded part, we take 1 minus that to get the shaded part. So let's go look up 1.02. So 1.0, okay, 2, remember that is actually the third column because this would be 1.00, this would be 1.01, this would be 1.02. We find 0.8461. That's not our p-value. That is no way going to be our p-value. It's 1 minus that. So 1 minus 0.8461. Okay, so actually let me, hold on, before you do anything here. This area here is 0.8461, okay? That, I got a little rambunctious here, okay? So this area, this unshaded part is 0.8461. We want 1 minus that over here for our p-value, okay? So that means our p-value, if you throw that in your calculator, I think you're going to get 0.1539. Now, I will say this, okay? If you're comfortable with that, fantastic. You can use the idea of symmetry, okay? And if you understand that, go right ahead and use it, okay? But that's where I'm going to leave it, that idea. I'm just going to go ahead and use this methodology every time when we're doing a right tail test. Okay? So it looks like 0.1539 is our answer. Okay? Alright, here's another right tail test. This time we have 3.04. So notice that StatCrunch doesn't even draw it. Why? Because it's such a small area right here. Here's 3.04, and so the area associated with it, I mean, is this tiny little area. That's probably even bigger than what I'm supposed to draw here. Because remember, this graph technically keeps on going this way and that way. Okay, so there's just a tiny bitty itty bitty area out here. Okay, I mean, it's hardly has any kind of area to it whatsoever. Okay, we're going to get a very small p-value in this situation. Okay, so 3.04. Now when we look it up, remember what the book's going to give us. The book is always giving us less than. So it's going to give us this unshaded part. It's going to give us all this stuff in here. Okay, but that couldn't possibly be our p-value, right? That's going to be way too large of a value for a probability based upon our drawing here, because we need this tiny little area right here. So it's going to be 1 minus whatever we look up. So let's look up 3.04. 3.04, where's 4? Right here. Okay, 3.0, 0.04, we see where that comes together. Okay, we get 0.9988. Okay, 0.9988 is this area right here, 0.9988. Okay, so what's the p-value? 1 minus that. 1 minus 0.9988, and we get, if you throw it in your calculator, I think you're going to get 0.0012. There's your p-value. There's your probability of that happening. Okay. So the probability of getting our p-hat 3.04 standard errors away, or more extreme than that, very small, 0.0012. Okay. So right-tailed, 1 minus the probability that you look up. Okay. Okay. Now, how about if we run a two-tailed test? Okay. So notice here we have a not equal to sign in the alternative hypothesis. Now remember what's going on here. You are testing both less than and greater than at exactly the same time. Okay. So you got to do something special here with the p-value. All right. So notice our test statistic here is negative. It's a negative 1.34. So I depicted it here on our standard normal table picture here. Okay, negative 1.34. It's right here. So what I'm going to do is I'm going to go to the nearest tail. So the nearest tail here, when it's two-tailed, this is only for two-tailed. Okay, we're going to go figure out the area to the nearest tail. Okay, so we would go figure out that area right there. Okay, but here's the problem. That's only less than. What we have to do is we got to figure out something as rare on the other side, as rare as this negative 1.34. You know what's rare as a negative 1.34 on the opposite side? It's a positive 1.34. Okay, and so here this is a positive 1.34. Okay, and so the combination of these two areas in red is the p-value. So this, okay, this area right here plus this area over here is actually the p-value. Okay, again, why are we doing this? Because we are testing both less than and greater than at exactly the same time, and we got to get us something as rare as being 1.34 standard errors away. Okay, and so that is both over here and over here. Okay, here's the thing, is that these two areas right here, this area right here and that area right here, is exactly the same when you're working with the standard normal table. They're exactly the same. Okay, so you just got to figure out one of the areas and do what with them? Either add it to itself or multiply it by 2. Okay, so if you figure out this area right here, you can just multiply it by 2 and you'll get your p-value. Okay, so let's try it out. Negative 1.34. Negative 1.34. Let's take a look. Negative 1.34. Where is that? Looks like about right about there. Okay, so what does that 0.0901 represent? That is not the p-value. What that represents is this area right here. Well, guess what? This area over here is also 0.0901. And so what would our p-value be? Either take these two numbers, multiply and add them up, or take one of them and multiply them by 2. Don't care. It's going to give you the same answer. What do you get? 0.1802. That will be our p-value then. So you got to remember, two-tailed test, not equal to sign in the alternative hypothesis. Okay, that you got to look up both sides, but they're going to be exactly the same area, and there you go. There's our p-value, 0.1802. Try another one. Okay, let's try one more. This time our test statistic is positive, is 2.78. So I depicted it here on our standard normal table. Picture, I should say. Okay. And here's 2.78. So hopefully you're drawing this with me. Okay. But is that the only area that we need to be concerned about? No. We also have to be concerned about that area, less than a negative 2.78. So notice I have this area over here, that area over there. Those two areas are exactly the same. Okay, exactly the same. Here's what I would do. Okay, if you have a two-tailed test, okay, this is what I would simply do, okay? Because less than always is going to be presented to you in the textbook, this is what I would do. Listen up closely, okay? Is that I would always look up, when you have a two-tailed test, look up the negative. No matter if, I don't care if this is positive, you're going to look up the negative. The negative is going to be this area right here, okay? Now, why do I want you to look up the negative? Because this area, you don't have to subtract from 1. So once you look it up, you know what this area is over there. I would always look up the negative value of this when it's two-tailed. Okay? There you go. You're using the idea of symmetry. Okay? 2.78. So now, what we're going to do, we're going to look up a negative 2.78. Negative 2.78. Here's a negative 2.7. Here's 0.08. We see where that comes together. I got here 0.0027. So that means this area over here is 0.0027. And guess what? This area over here is also 0.0027. Okay? So what's the p-value then? Well, you would add them up or multiply them by 2. I see 0.0054 for our answer. Okay? You could look up the right-hand side. You could look up this, okay? And what it would give you is the area from here all the way over to a negative infinity. So when you look it up, you probably would have found 0.9973. Okay? It just makes it harder. Okay, because you got to take 1 minus that, you get 0.0027. You know that this area over here on the left-hand side is 0.0027. So you can do it that way. It's just that it's an extra step. Okay, to me, if you have a two-tailed test, no matter if the test stat is negative or positive, look up the negative. It'll give you the area over here. You know that's equal to the area over here, and you're all set. So there's how to calculate the p-value when your test statistic is in terms of z, okay, in terms of z, all right? So thank you for your time. If you got any questions, let me know. We can always set up a WebEx and chat about this stuff. Thank you.